Welcome to Get Your FRQ On. This question is from 2024. It is question 2, and it is calculator active. In the question stem, we have a particle moving, and we are given a function for the velocity of the particle at a time t. In part A of the question, we are considering the interval from 0 to 2, and we are asked to find a value t sub r for which the particle is at rest. And then we are asked to determine if, for values of t between 0 and this t sub r, whether the particle is moving to the left or the right. So the particle will be at rest when its velocity function is equal to 0. It's a calculator active question, so we can take the velocity function, set it equal to 0, solve for that on our calculator, however you please. And it turns out that the velocity will be 0 at this value t sub r equal 1.426. All right, now, if we have a graphing calculator, we can look at the graph of this velocity function. And since the velocity is 0 at this time, we can look at the graph of the velocity function. We note that the graph of v of t changes from positive to negative at this value t sub r equals 1.426, which indicates that for values of t between 0 and t sub r, the velocity was positive, so the particle was moving to the right on that interval. In part B of the question, we are asked to find the acceleration of the particle at 1.5, and then is the speed increasing or decreasing? So first, it's customary to understand that acceleration is the derivative of velocity, but if you're going to use the notation a of t for acceleration, it is by far in your best interest to explicitly state that you are defining a of t to be the derivative of v of t. Right? That way you can justify using that notation specifically for acceleration. Otherwise, if a of t is just some function without a clear definition, it isn't clear to the reader what function you're actually evaluating, and so there's a good chance you would not earn points. All right, so explicitly define a of t to be the derivative of our velocity function. All right? This is a calculator active question. So we can figure out what a of 1.5 is simply by evaluating the derivative of our velocity function at 1.5. And it turns out that a of 1.5 is negative 1. It's actually not negative 1, but it turns out to be like negative 0.9999 something. So, in terms of how accurate you need to be for the AP exam, you can call it negative 1, and that would still be okay. And ultimately, for the second part of the question, where we need to determine if the speed of the particle is increasing or decreasing at t equals 1.5, we do need to note that the acceleration at 1.5 is negative. All right, now to answer that question, we know that the acceleration at t equals 1.5 is negative. We also need to know the value of the velocity at 1.5, but since it's a calculator active question, we can just evaluate the function at 1.5 using our calculator. It's negative 0.077, which is also less than 0. And then because acceleration and velocity at 1.5 are both negative, they have the same sign, which is an indication that the speed of the particle is increasing. In part C of the question, we are given an initial condition that x of 1 equals negative 3, and then we are asked to find x of 4 with work. Basically, all we're showing is what is the position of the particle at t equals 4. All right, so we're given x of 1 is equal to negative 3. This looks like an initial value problem, so we're going to set up the appropriate integral. X of 4 would be x of 1 plus the value of the integral from 1 to 4 of v of t dt. Substituting in the fact that x of 1 is negative 3, we get negative 3 plus the integral from 1 to 4 of v of t dt. But again, this is a calculator active question, so we can calculate this definite integral using our calculator, and when we do, X of 4 has position negative 2.803. In part D of this question, we are asked to find the total distance traveled by the particle on the interval from t equals 1 to 4. So recall that the formula for finding total distance traveled is basically the displacement formula, only now we're taking the absolute value of the velocity function. So the total distance traveled will be given by the integral from 1 to 4 of the absolute value of v of t dt. But again, this is a calculator active question, so all we have to do is slightly modify our function v of t to make sure we're taking the absolute value of it, ask our calculator to calculate the definite integral, and it turns out that the total distance traveled by the particle between t equals 1 and 4 is 0.958. All right, so between t equals 1 and t equals 4, the particle traveled a total distance of 0.958. This has been Get Your FRQ On. Don't forget to like and subscribe if you liked this video, if you learned something from it, or if you just found it entertaining and informative.